Starting the notes right here on 1.6, 1.7, starting with this class opener. It says label the coordinates and state which quadrant they are in or between. So let's start with point A. From the origin, obviously it's 3 on the x, 4 on the y. So the answer to point A, or the location of point A, is 3, 4. Remember, these are ordered pairs. You have your x on the left side, your y on the right side. Let's go to point B. From the origin, you go -1 on x and +3 on y. So B is really -1, +3. Back to the origin, let's go to C. Do I go positives or negatives on x? I stay at 0 on x, and I go down to -2 on y. So my coordinate, my location of C is 0, -2. That's what I'm going to write over here, 0, -2. And D is over here, 4 on x, and I don't go up or down, so I stay there at 0. So it's 4, 0. My location of point D is 4, 0. Now let's go back and remember that quadrant 1 is this upper left quadrant. Quadrant 2 is the quadrant 1 is the upper right quadrant. Quadrant 2 is the upper left. Quadrant 3 is the bottom left, and quadrant 4 is the bottom right. It is counterclockwise, so point A is definitely in quadrant 1. Point B is in quadrant 2. Point C is between quadrants 3 and 4. 3 and 4. Okay. And point D is between 1 and 4. That was the class opener. Let's move on to today's notes. Functions and relations. In this section, we need to define and understand what a function is and compare it to a relation. A function is like a machine. So you guys have this blank spot right here on your paper. You need to draw this machine right here. So if you're at home watching this for the first time, hit pause. Try to draw a machine like this that has a window, that has an opening, because this is where we're going to be putting in numbers, and something's going to happen in the machine, and you're going to get out your answer on this side. So once again, we are going to be inputting right into the machine right here. It's going to go through the machine, and it's going to come out over here, output. Okay? So go ahead and draw this machine, hit pause, and then hit unpause. Do your best. I know you might not have the same artistic abilities as me. But anyways, try to draw any machine. Hopefully you took the time to draw it and hit pause, and now you hit unpause. So let's continue with this, and let's plug in a number. Let's say 2. Okay, so let's pretend that this 2 is going right into this machine, and it comes out as a 5. Interesting. Okay, so how about we plug in the next number? How about 3? We take the 3 and we plug it in, and it comes out as 7. Interesting. Or how about we take the number 5, and let's plug in this green number 5, and you plug it into the machine, and as it goes through here, it comes out, can anybody guess? It comes out 11. And you're thinking, what the heck? How's he getting these numbers? Okay, so the numbers that I'm putting into the machine, this is really going to be a function. And what am I doing to the 2 to get out of 5? You probably think, oh, well, maybe he adds 3. 2 plus 3 is 5. So maybe in here, the machine is just adding 3 to it. But if you try 3 and you go 3 plus 3, that gives me 7. That doesn't work, because 3 plus 3 is supposed to be 6, and this says 7. So I cannot be adding 3. But it was a good guess. Maybe you're adding 3 to the inputs, and that's how you get the outputs. So how do we get from here, from 2 to 5? Well, let me tell you, inside here, if you were to look inside the window, what's happening is y equals 2x plus 1. Okay, now what does that mean? That means that I'm plugging in the 2. I plug in the 2 right into the x, and that would be 2 times 2 instead of x. What's 2 times 2? it's 4, and 4 plus 1 does give me the 5. Okay, so you might have not thought of this function, but you could have seen the pattern and said, okay, 2, if I double it and add 1 to it, I get 5. 3, if I double it and add 1 to it, I get 7. 5, if I double it and add 1 to it, I get 11. Let's just try one more for kicks here. What if I plugged in the number 10? Whoops, that was ugly. Hold on. There you go. That 10 looks better. Plug in that number 10. You're going to get out, doubling it, 10 times 2 is 20, plus 1, you get out 21. So do we see how this function is working? It's like a machine. You plug in a 2, you get out a 5. You plug in a 3, you get out a 7. Plug in a 5, get out an 11. Plug in a 10, get out a 21. So you could plug in as many numbers as you want, and you could pull out as many answers as you want. But let's first start by understanding that, and you could go back and underline this, a function is like a machine. Okay? You put in some inputs, you get out some outputs. So that's why I also have this right here. All of these words mean the same thing. Okay? The inputs obviously are the numbers that are going into the machine. And when you get the answer out here, that is no longer an input. The 5 is no longer an input. That 5 is now an output. So all of these words mean the same thing for the numbers that come out. So once again, all these words are different words for the numbers that are going in. All of these words are the different names of the numbers that are coming out. So sometimes we refer to these numbers 2, 3, 5, and 10. Sometimes we refer to them as input values. Or sometimes we refer to them as domain values. Yeah, it's kind of weird. These guys are called domain. They go in. And the output, these answers, these are called range values. Okay? Or this is an obvious one. Sometimes these numbers are called X values. Now, why would I call 2 an X? Because that's where you plug it in. You plug it into the X. And if you actually work it out, 2 times 2 plus 1, you get 5, but it really says Y equals 5. So why do we call the 5, the Y values? Because that's what it is. So sometimes the numbers that are going in, actually all the time, they are the X values that are going in, and the answers that come out, those are the Y values. And finally, I have this written in. You don't have this in your notes, so please write it in. The numbers that are going in are your independent variables, and the numbers that are coming out, those are your dependent variables. Okay? You're plugging in a 2. Now the answer that comes out, the 5, it depends on you plugging in 2. That's the only way 5 is going to come out, if you plug in a 2 right there. If you plugged in any other number, 5 is not going to come out, right? So the outputs depend on the inputs. That's why these guys are independent and these guys are dependent. Okay? I hope this kind of makes sense to you guys. Let's jump down here. The most important fact of the day with regards to the functions. We have to know this, guys. We have to memorize this. For each input, there's exactly one output. In other words, if you plug in a number and you get out an answer, then you plug in that same number again and you get out a different answer, then it's no longer a function machine. The machine's messed up. If you plug in one thing, you have to get out only one thing. If you ever end up with 2 outputs for your one single input, then you cannot consider that a function. It's just a relation. So let me try to explain that whole paragraph with a little more tangible concept here. Let's pretend that this is not an algebraic function machine. Let's pretend it's a tortilla machine. Yeah, it makes tortillas. Okay, so as I plug in numbers, or let's say I plug in some dough, I get out a tortilla. If I plug in some more dough, what am I going to get out? More tortillas. Plug in some dough, get out a tortilla. Plug in some dough, get out a tortilla. Plug in some dough, get out a tortilla. That's what it's supposed to do, is a tortilla machine. But if I plug in some dough and I get out a donut, what the heck? That tortilla machine's broken, right? If you plug in the number 2, it better give you out a 5. If you plug in the number 2 again, it better give you out a 5 again. Okay? So for each input, there is exactly one output. If you ever plug in a 2 and get out a 5, and then you plug in a 2 again and you get out 10, then that's broken. That's a broken machine. It's no longer a function machine. That's what we just call a regular relation. That means that there's some type of relationship going on between the numbers but we can't actually put it into a function that says y equals 2x plus 1 or something like that. Okay? So once again, for each input, there's exactly one output. Let's take a look down here at our input and output values. So in this case, the input is 1. It gave us the output 3. Okay? The input 2 gave us the output 4. The input 3 gave us the output 5. The input 8 gave us the output 10. Now, at this point, I'm not even asking what my function is. Who cares about the function? All I'm asking for, is this a function machine, or is it a broken machine that we would have to call just a relation? Okay, so this right here is a function. This right here is a function. Why? Because I never plug in the same number 2 times. I plugged in a 1, got out an answer. Plugged in a 2, got out an answer. I never plugged in another time, like there's no 1 here or 1 here or 1 there. So if I plugged in a 1 and got out a 3, and I plugged in a 1 again and I got out a 10, that's when you know the function machine's broken, and it cannot be called a function, it's just a relation. Okay? So let's take a look at this next one right here. This next one right here, and notice that I changed the words. I call these inputs. It's the same thing as domain. It's the same thing as x values. These are outputs. This is the range. Outputs are the same thing as range, which are the same thing as the y values. So I'm just changing up the vocab on each one of these. But anyhow, on this one, -3, it gave me a 15. I plugged in a 1, it gave me a -5. I plugged in a -3 again. Okay, so that's the key right here. I plugged in a -3, that gave me 15. I plugged in a -3 again, and that did not give me 15. It gave me something totally different. That means it's a broken machine. It's no longer a function. It is just a relation. Okay? So this one's a function. This one's a relation. Why? Because the machine's broken. So let's take a look at this next one. On this next one, you have your x values and your y values, which are really your input values and your output values. So you're probably thinking, wait, this is really weird. All these answers are 3. This machine must be broken. No, it's actually not broken. You could actually write it's really simple to see the equation, the function that it is. It's y equals 0x plus 3. See, that would be the actual function machine. Now, I'm not asking you to find the function machine. All I'm asking for is it a function or is it just a relation? If the machine's not broken, that's a function. If the machine is broken, that's when you call it a relation. But as you could see here, if I took the 4 and plugged it in, 4 times 0 is 0, and then plus 3 would give me that output 3. The input of 2 times 0 is 0, and then plus 3 would give me 3. The input of -7, 0 times -7 is 0, plus 3 would give me the output 3. The input of -2 right there, -2 times 0 is 0, plus 3 is 3. So this really is a function, even though it looks weird because your outputs are all the same. That really is a function as well. The machine is working. So we will have to do this on the quiz Friday and on our homework for this section. I want to give you different examples, and you need to state whether it's a function, a machine that works, or it's just a relation that's a broken machine. I'm also going to have you analyze graphs. So if we look up here, we have some graphs, and you're going to have to look at this graph and determine whether it's a function or just a relation. So let's think about this. For each input, there's exactly one output. Each graph is actually infinite amount of coordinates. So I have some coordinates at 0, 0, at 1, 1, at 2, 2, at 3, 3, at -1, -1, -2, -2. So if I wanted to, I could make a list of coordinates, right? 0, 0, 1, 1. And if you look at those x, y values, those are really input-output values. Notice, do you ever plug in the same number 2 times? No. So this is a perfect function. It is a function, right? So let's just put an F right here. That's a function, okay? Now, instead of doing this, because this is kind of a waste of time, instead of actually listing your coordinates and checking to see all your input values and see if it repeats and it gives you a different output, instead of doing that, there's this thing called the vertical line test. So as we read up here, it says to apply the vertical line test, run your pencil a vertical line up and down like the y-axis, run it left and right along the x-axis, see if the graph ever has 2 points touching your vertical line. Then that means that for your one input, your x value, you have two outputs, y values, which means that it's not a function, just a relation. So if I take this vertical line right here, let's pretend it's a pencil or something, and if I start running it and I stop right there, I have a point right here. And if I move it on and stop right there, there's only a point right here, right there. And as you could see, if you run the red line, never at any point does your actual graph cross that red line at more than 1 point. Okay, so for each input, there is exactly one output. So if we go over here to this line, to this graph, that also passes the vertical line test. Okay, so automatically, without even having to think of inputs and outputs, we know that this guy over here is a function. Okay, because it passes the vertical line test. Now let's take a look at this one down here. This one fails the vertical line test. This one fails the vertical line test. Let me move this up a little. Get that pencil. It fails the vertical line test. What do I mean by it fails the vertical line test? Do you guys see how the red line that I'm moving touches the graph right here and here? Okay, let me actually move that out of the way. Let me move the pencil out of the way. Whoops. Let me see. Move. There you go. So let me show you that dot and that dot. That's where the graph touches my vertical line at two different places. Okay, so what that means is that for the input, remember input or x values, for the input of 4, I actually have two outputs. The input 4 gave me the output 2 and also -2, right? I mean, after all, this is a coordinate 4, 2, and this is a coordinate 4, -2. So what does this mean? It means that my input 4 gave me a 2, my input 4 gave me a -2. That's a broken machine. Again, if you plug in a 4 and you get out a 2, if you plug in a 4 again, you better get out a 2 again. That means that the machine's working. So in this case, when I plug in a 4, I get out a 2. I plug in a 4, I get out a -2. That's like plugging in some dough and getting out a tortilla, plugging in some dough, and then you get out a donut. That doesn't make sense. That's a broken machine. So right here, same deal. The vertical line, look, boom, it's touching at two places. Even here, it's touching at two places. Right here, it's touching at two places. Right here, it's only touching at one. But yeah, this whole thing fails it. At any point, if your graph touches it at more than 1 point, right here, it clearly touches up here and down here. It's touching at more than 1 point. That fails the vertical line test, which means that this guy is just a relation. Okay, it's just a relation. Going over to this side, this passes the vertical line test, so that is a function. Let's put an F right there, function. And going down to this graph down here, I don't know if you could see it, the print didn't come out that great, but this is a line that's running perfectly up and down. Okay, so if I do take my vertical pencil and run it side to side, boom, it touches and all the points are in common. So for all the inputs for the input 2, it gives me an infinite amount of outputs. In other words, if I were to think about this guy in terms of coordinates, the coordinate 2, 0 is there, the coordinate 2, 1 is there, the coordinate 2, 4 is there, the coordinate 2, -4, 2, -2. So as you can see, this is a really broken machine. The input 2 gave me the output 0. The input 2 didn't give me 0, it gave me 1. I keep plugging in the same input and I keep getting out different outputs. So that fails the vertical line test. So that one's just a relation as well. Okay. Jumping to this next section, it says determine if the graphed coordinates of the class opener represent a function or a relation. So if we go back to the class opener and we look at these dots A, B, C, and D, is it a function or is it just a relation? You could use the vertical line test on that guy. And let's see, right here, it only touches at point B. That's fine. Let's move on. Right here, it touches at the C value. Right here, just at A. Right here, just at D. So for each input, there is only one output. Never do we end up with 2 dots on the vertical line. That would make it a broken machine. If I ended up with 2 dots on the vertical line, then that would be a broken machine. You would call that a relation, not a function. So the correct answer to that one is yes, it is a function. Please state the range of the class opener. Well, remember our vocab words. Range is the same thing as outputs. It's the same thing as the y values. They're the same thing as the dependent values. So when we look at the range of the class opener, all we need to state are the y values, 4, 3, -2, and 0. And now for the domain of the class opener, let's just, what is the domain? The domain is simply your x values, right? It says right here, input values are the same thing as the domain values, the same thing as x values. So let's go to the class opener and let's just state our domain values, which are our x values, 3, -1, 0, and 4. Let's go back, 3, -1, 0, and 4. And that's what I write right here, the domain, 3, -1, 0, and 4. Those are the domain values of the class opener. Let's move on and try question 4. If you have 2 different domain values producing the same range values, it cannot be a function. True or false? That is false. Okay. Because, like, let's say y equals 0x plus 3, right? If you plug in 1, you're going to get 3 as an output. If you plug in 2, you're going to get 3 as an output. And that's exactly what this is saying. You have 2 different domain values, 2 different domain, which are x values, producing the same range value, producing the same answer, 3. That's a perfectly understandable function. So that's false because it is a function. It says right here it cannot be a function. Let's see this one. If you plug in 3 and you get out a 4, then you plug in 3 again, but you get out a 2, then it's not a function, it's only a relation. That's true, okay? Because that would be a broken machine. That's what we just call a relation. So I hope this helps. There will be other videos on the homework.